Assalamualaikum and hi everyone. My name is Muhammad Syami bin Sadudin and I'm representing my group from Group 1 and we are going to present about talk. For further information, I would like to pass this presentation to my friend named Muhammad Syazani bin Zamri for the introduction. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Syazani bin Zamri and I will explain about the definition of torque. What is torque actually? Okay, torque is a measure of the force that can cause an object to rotate about an axis. Just as force is what causes an object to accelerate in linear kinematics, torque is what causes an object to acquire angular acceleration. Torque is a vector quantity. The direction of the torque vector depends on the direction of the force on the axis. Torque can be either static or dynamic. If the torque is static, torque is one of which does not produce an angular acceleration. If the torque is dynamic, it's just like the drive shaft in a racing car accelerating from the start line, because it must be producing an angular acceleration. Next, I will let my other group mates, Haziq, to continue our presentation.
Assalamualaikum and hi. My name is Muhammad Haziq and today I'm going to present to you about torque. So I choose simple plank and beam problems for you to solve. So here's my question. Okay, so let's get to it. I will present torque, simple plank and beam problems. So for this question, it is a statically equilibrium, which is it is a static object. The object doesn't move. There are two conditions, which is the first condition is the total of force must be zero, which means it is not moving from places to place. For the second condition, it is a total of torque equals to zero, which is preventing the object from rotating. So for the equation for this question is total of torque counterclockwise equals to total of torque clockwise, like so. Okay, we're moving on to the question solving. Okay, so we're moving on to our free body diagram, which is the beam. It was given that it has 3 meters long and 7.5 kilograms, and the object on the beam is 67 kgs, and the force that we want to find is one at the left, which was the value. It didn't give in any value here, but the distance from the force to the pivot is 1 meters, and the distance between the object and the pivot is 1.5 meters. Okay, another thing we should know that if the question give us the length of the beam and the weight of the beam, the force acting on the beam should be at the middle, so we put another arrow here. Okay, after that we find the value of force acting at every arrow here. So the one at the right is 67 kg times 9.8. The one at the middle is 7.5 times 9.8, and at the left one is we don't know the value yet.
Assalamualaikum and hi, my name is Muhammad Hafizuddin bin Muhammad Zudi, and today I will continue the calculation for the simple question. So before we start the calculation, we need to draw the free body diagram. So this is the free body diagram for the question. So we have horizontal beam, object and fulcrum. The question is we need to identify the force that is required to keep the beam horizontal. So first, as we know, sum of torque in counterclockwise direction is equal to sum of the torque in clockwise direction. So we use this equation to solve and to find the force that we need to keep the beam horizontal. So we just add the value in this equation So in counterclockwise direction, we have force times 1.0 meter. 1.0 meter is distance from the force to fulcrum, is equal to sum of the torque in clockwise direction. First, we have 7.5 kilogram times 9.8. This is we use to convert kilogram to Newton, and times the distance from midpoint of beam to fulcrum 0.5 meter plus 67 kilogram times 9.8 Newton times the distance is 1.5 meter. So we calculate this value and we get 36.75 Newton plus 984.9 Newton. So we have 1021.65 Newton. So we need to find the force. So the force is equal to 1081.65 Newton divided by 1.0 meter. So after we divided the sum of torque in clockwise direction with 1.0 meter, we get the same value, that is 1021.65 Newton. And this is the force that we need to keep the beam horizontal. That's all from my calculation. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Ikmal and I'm going to give a few examples of applications of torque in real life. Whenever there is a force causing a turning or rotating movement, torque is bound to be produced. In real life, you may not realize it, but there are many applications of torque that are happening all around us. To give you an idea, here are some common applications of torque that you may find interesting. The first example is wrench. If you have ever used a wrench, you will get the idea of how torque is applied. When you use a wrench to tighten or loosen a nut around a bolt, you apply a pulling force around the rotation axis of the nut, allowing the torque to happen and rotate. If you want to increase the torque for turning the nut around the bolt, you will have to increase the distance of the force application point to the pivot point or increase the amount of force being applied. The next example is hinge door. Another common example of torque in everyday life is hinge doors. When you open a door, the torque applied in the situation allows it to move around the rotational axis. Here, the pivot point is the hinges, and if you apply force near the hinges, you are likely to face difficulty in opening it. On the other hand, when the force is applied at the furthest end from the hinges or the door's knob, you will see that it is much easier and you will have to apply a lot less force in opening it. That's all from me.
Assalamualaikum and hi everyone. My name is Muhammad Shahmi bin Sarudin and we meet again for the conclusion. First of all, before ending our online learning session, there are some things that you should remember before this class ends. First, torque is a measure of the force that can cause an object to rotate about an axis. Second, torque is a vector quantity because it has both scalar and magnitude. And torque can be either static or dynamic. And third, static torque is the one does not produce an angular acceleration. And for the conclusions, torque is one of the most important things for us to do our daily activities. Because without torque, we cannot even to open and close the door. So I think that's all from us for now. I hope all of you enjoyed this presentation and this will be beneficial to all of you. Thank you for watching. Assalamualaikum and bye bye.